Now it's time to talk about conditionals. Conditionals go back to the very fundamental thing that build up all computers, and that's binary. That's 1 and 0, true and false, on, off, this, that. Now, conditionals themselves really help us control the flow of our program. That is, if one thing happens, our program can do one thing. If another thing happens, our program can do a completely different thing. It's really cool and very important as a concept itself. But the understanding of it is very simple. It's much like a light switch. The light switch is either on or it's off. It's not really any other thing. It's not going to be ambiguous there. It's one or the other. That's what's really nice about conditionals, and that's what we're going to be talking about here. Now, for Python itself, we're going to be using conditionals as Boolean values. That is true or false. So true or false, one or the other, and we're going to be able to design our programs in such a way. Now, in order for us to understand how to use a conditional, we actually have to understand how to develop some sort of Boolean value from data. And that's what we're going to do right now. So we're going to actually take a look at various expressions that we can use to actually show conditionals. So the first kinds of expressions go to a data type called a Boolean value, and that is true or false. Now, notice when I type out true or false, we don't get any sort of type error, and it's not thinking that it's a variable. It's actually treated as true or false, one or the other. Contrast that with lowercase true. That's a variable now, and that is actually a variable that's a really bad variable. You wouldn't want to call it true in pretty much any programming language, so you would never want to say true equals to true or some string. That's just going to get things very complicated. Really, when true is not defined, or when false or lowercase false is not defined, you want to see this error. So that's something that's really important too, especially for other programming. But true itself is true. False is false. So if I said print true equaling to true, it gives me this answer of true, right? So equals equals is saying, is doing that comparison. It's doing the conditional expression. So like if I use the string Justin and I put that equals equals to the string capitalized Justin, it gives me false. If I change it to being lowercase Justin, it gives me true, right? So that is a conditional expression where we could also just say true. So if I wanted to, I could set a Boolean value. So I'll say object A is true and object B is false. So I can do object A equals equals to true. It's going to check if it's true, and that's what it's going to say. Now, if I did name equals to Justin, and I said name equals equals to true, we're going to get false, right? So it's because it's not equal. They're not the same. Now, there is something very important to note here is when I set a variable, I use one equal sign. When I compare the variables, I use two equal signs. That's fairly common with programming in general, but it is something that is important to note, especially when you're doing these conditional statements. Now, we can compare all sorts of things. We can do all sorts of conditionals. So let's do another one. Let's do one with lists. And I'll say list is 1, 2, 3. List A is 1, 2, 3. List B is equal to 1, 2, 3. And then finally, list C is equal to, and this is going to be 4, 5, and 6. So I can print out list A equals equals to list B, and I get true. I can also print out list A is equal to list C. I get false. And I can finally say list A is not equal to list C. So this is a new kind of expression. It's that exclamation mark equals. So if I wanted to use that exclamation mark equals, I could probably do it with object underscore A, but I can't. So if you're coming from a different programming language, this is an error that you might see or you might not expect to actually happen, right? So this is not the inverse of it. So to do the inverse of it, you would say not object A, and that gives you the inverse. So you just write out not. Not is another example of a variable you would not use. Don't use not as a variable. Very simple. So what I could do here is, let's say object B, we said that was false, so I can also do print not object underscore A equals to object B. So what I'm doing here is I'm comparing the opposite of object A with not, and I'm comparing it to object B. I press enter and it says true. Well, let's change equals to is. That is also true. That's another way to evaluate a conditional. So there's definitely some more stuff that we can do here. So let's go back to that name of Justin, right? So name is the variable, and if I print out the length of this name, so len of name, I'll see that's 6. So I can do a comparison with the number 6. I can also do a comparison if it's greater than or equal to 6. So this is a math function. We'll discuss more math later, but I can press enter and we see true. So greater than or equal to. And we can also do less than or equal to. And of course, it's going to continue to say true because it's equal to 6. If I said less than 6, it'll say false. If I said greater, it would also say false. And if I tried that exclamation mark, not, or like basically the reverse of that, it doesn't work. So there are some sort of evaluations that might seem intuitive that just aren't there. So that's something else that you might consider. So we can do a few more math things here. Let's go ahead and discuss some of these. And I'm going to do print 100 minus 32. So that's 68. So we're going to compare that it's not equal to, say, 93. That's also true. Cool. Not a big deal here, right? We can also print 5 plus 5 equaling to 10. So equals to 10. True. Also not a big deal. We can do division. So 10 divided by 2 equals to 5. Great. Fairly straightforward. We can do an exponent. So 3 star 3. So that's 3 to the third power. We can say it's equal to 9. That's not true. We can say it's equal to 27. That is true. We could also do 50. This is something that you might use in the future, and that's 50 modulo 2 is equal to 0. So that percent sign is modulo. That's a concept that we will talk about later, but modulo is basically saying the remainder. So 50 divided by 2, what is the remainder? And that's going to be 0. So 50 divided by 2 is 25 with 0 remainder. Now 51 divided by 2.0 is 25.5. So if I did 51 modulo 2, I would get 1, right? So that's the remainder. So we can do these kind of conditional expressions for all sorts of things. And like I said, it will help us control the flow of our programs. So what we want to do now is actually run some conditional statements inside of some loops.